Okie dokie. Right, so I've got this set up now. It's been going for a little while. Let's just get that light a bit better for you after it changes around. So we've got a solid 35 milliamps on the quiescent current there, a little bit there, slightly over, and slightly over 35 milliamps there. We've got no external cooling on at the moment, and I've just allowed this just to sit and go with temperature. We're on 55 volts, as you can see over there, and on our signal input 1 kilohertz, 30 millivolt. Now I'm going to jump that up pretty quickly because this is warmed up. I'm going to take it up straight up pretty much to a volt and see what we get out there on the scope. Now what I've noticed with this as well, this is what I'm going to show you. I'm not going to tell you so much about it. I'm going to show you what I've noticed with it. So let's turn this on first. You're not going to see a lot over there because it's set at 10 volts per division. So let me just make sure we're on the right parameter here. I'm just going to take that up to 100 millivolts, and then just start switching out. So we're going to 5. I'm just going to turn that down for a second because I just watched those needles just shooting across. I'm just going to back those off to 1 amp. Let's start taking it up. So let's put that on 5. So as you can see there, we're on a little bit over 200 milliamp. So if I'm wobbling around, don't worry about that. It will go up in a second. So let me just take this up 80. There we go. As you can see, so that's on. It's just going on 1 volt. 1 volt. 400 milliamp. And just below 400 milliamp there. Okay. So not a problem. Now, if I put the cooling on now, it's gonna not make a difference, but it just will help out with just keeping the whole thing cool, including the dummy load, which tends to get warm, and I've put it on there. So even though this isn't a great deal, look, I've already got just over 6 volts going into this for both of them, but it's going to give us enough cooling just to see. In actual fact, that could have been something that I showed to you straight away. Never mind. I was just going to show you the difference between having the cooling on this slow fan just blowing a bit of air over this and its quiescent current, and how it brings down the quiescent current quite a bit with the cooling on. Now, as you can see, look, it's dropped down to 52 volts on the other screen. I'm going to continue to go up this, and I'm going to go up in 100 millivolts at a time, just keeping an eye. We're on 1.3 there. I've gone up to, that's on 600 millivolts nearly, and I'm going to go up to, as you can see there, right. So there you can just see on the scope now a little bit not so clever. Okay, but this is what I want to show you. Because that was on like 55 volts about, wasn't it, to start off with. So this is what I want to show you. As I turn this up, you might expect it to clear up, and you can see there just over 800 milliamps. Now if I start turning up the voltage, you see what happens? Now remember, this is set up for 70 volts. If I turn down the voltage, we can clear that up. But we start clipping off if I turn down the voltage too much. So if I set it to about there, that looks to be about the best. So we're on just under 800 milliamp. Just under 800 milliamp. And we got 13.2 volts across there. And forget what that says for a minute on the multimeter. I'm going to start backing this down all the way back to 0. Here we are. And then look at that meter. Yeah. So 55 volts. It seems that you get better performance out of this. What you've just seen there is the best that I can get. 13.3. Around about 55, 56 volts on the input. In actual fact, what I'm going to do is I'm going to turn it down, because I've got to experiment at this point now where anything at 55, it's getting the transformer for that. Yeah, getting the transformer for 55, 56 volts. You need a 20 volt transformer output, times that by 0.414, that's 28 point something volts. I'm not doing this in my head, it's from memory. Double that, 56 volts. So, but trying to find a 20 volt transformer with two secondaries, 20 volt on the output, is quite difficult. I found a 22 volt, and I'm thinking I may have to just modify the outputs of this with some diodes to accommodate, because there's no point me trying to run the other channel at its full potential when I can only run this how I can run this. Now, if I refer back now to the images, and I'm going to try and do this from my head, and because I'll put the image up on the screen now, you can see that the layout for this, the two channels, is slightly different. The channel on the right is going to be the right hand side channel, which is the one that gets 15.6 volts RMS on the output, and this, the channel on the left, is the one that's under test at the moment, is the one that gets lower. Is it something to do with the way I've laid out the tracks on the channel, with the way it's laid out? Possibly. I don't expect to get full potential. We're going to come back to this now, get rid of that picture. I don't expect to get full power out of the circuit like suggested in the documentation online for this at soundwhistles.net, which I suggest you go and have a look at for yourselves. Just because it is quite specific on the components it uses, and I've not been so specific. It's quite specific on the layout and on the way it is on the board that they suggest that you buy from them, which is probably very good, because they've designed, or they've modified this original 70s design to make it better than what it was. So I don't expect to get what they get from it. But I was really happy with the 16.5 volt RMS, especially as I'm going into 6 ohm loads. That's pretty good. So I'm not unhappy with this. I'm not unhappy with this at all. But I'm wondering now whether it's because of the layout. I'm using pretty much the same components. Now, there's a whole thing about this matching of the transistors, but I've been reading, and it seems like you don't really need to match these output ones so much. It's more to do with the input side, and that would probably, because, well, reading about matching these transistors is not just about betas or HFE. There's a lot more to it than that. And on soundwhistles.net, actually, in fact, there is a design for a jig, so you can check and match your own transistors. But there's a lot more to it than what I first thought, just by sticking onto a meter and just seeing if you get close betas. Because when I've looked for the better suggested chips for these on Farnell, which is where I just looked, just because I know DigiKey, yes, I do have that whole cart for DigiKey, but you got to spend a lot more money on that, otherwise you've got to pay an excess charge for shipping, and it's quite an expensive amount, and you pay a lot less on Farnell for the shipping, or you just have to make a £20 order and you're going to get free shipping anyway, which is better than like a £40 order or £36 order, whatever it is, with DigiKey. But when I look at the chips on there for the better ones, NPN and PNP, I hope that's the right way around. I've just pointed to those. There's on the NPNs, it's like there's a beta of 60 something, and on the PNP there's a beta of like 10. So if that's what they're advertised with, how can you match those on betas and expect to get what you may think, naivety wise? Of course, you guys out there who know about this stuff, you're going to know that's not correct. But for someone like me who's just learning, and you maybe think that it's like that until you've read enough and you realise, okay, that's not the way it is, then you can see that there's a little bit of difference there. So, very quick power test, and that is the best that I can get, and it's around about 55-56 volts. If I just turn this up to 56, I'll probably be able to set up for myself, because there's going to be a bit of fluctuation, you see, but I'll probably be able to set up for myself with a 22 volt output. This has got 24, 25 volts. I can't quite remember. I wonder if we can see that down there, actually, on there. I can't see it so well from here. 24 as you can see, look, 3.33 amps. Okay, so that's a little bit too much for this. So with just the 2 volts off on the AC, and that's going to make a difference. But if I just turn that up now with the 56 volts, as close as damn it to it, if I just start turning this up, I've got the cooling on, haven't I? Yeah. And I'll also show you the difference between having the cooling on, having the cooling off. Anybody who knows these will know the difference anyway. So you can start seeing, look, you start seeing that clipping, quite symmetrical, top and bottom, but still clipping. Voltage there, 50.9. If I just back that off, I suppose there would probably look the nicest, but I'm going to say there with a slight adjustment. And if I go up, if I turn up the voltage slightly, because remember it says 70 in actual fact, I'll tell you what, I'm gonna back this down. I'm gonna back this down just to show you at 70 volts. So we're gonna turn it to 70 volts, and we're gonna see. I'll have to go into the 10 amp range. So let me just take that up to 70 volts. So there we go. 59. Oh, now I've got to be very careful about quiescent current here. This is the sort of thing we don't really want to fall into. So let me turn off this input and switch back down, so we see in here what our quiescent current's going to be doing, going up. So I want to make sure that I keep that within the range of what it's supposed to be, which is the absolute maximum 100 millivolt. So as I start turning this up, and you see the quiescent current. So we've got 60 volts, and it's going to go up. And remember, I've got cooling on at the moment, so this will be different with no cooling. It's just going to get warmer and warmer and go up and up. So that's 66. I'm going to start backing this quiescent current down. I should probably, no, it's alright, we can readjust anyway. It just means that this video won't be as streamlined as what I hoped, but I just want to show you the bits that are more noteworthy rather than just listening to me gibber. Right, so that's 67 volts, and we've got to remember we're going to have a little bit of fluctuation. So I'm going to show you at 70 volts what happens when we turn off the cooling. So even though that is just above 30 millivolts, milliamps, sorry, per rail, I'm now going to switch off the cooling. I'm going to switch off the cooling, and you can see for yourself this rise, and you can probably see it rising quite dramatically there. Not as in just banging up 10 millivolts at a time, but you can see it rising. It's not something that you have to wait too long before it starts happening. Sorry if I haven't got both those in. I'm trying to stop my arms from shaking. This big glass lens in my hand, which is quite heavy. But I think you can see, look, we've not even got past a minute, and we're up 5 milliamps. And we're still continuing to go. So I'm going to go up a little bit more, and I'm going to flick the cooling back on again. It doesn't need a lot of, oh, look at that lot. It doesn't need a lot of cooling, it just needs a little bit of, just a bit of airflow around those heat sinks, just to really just gently blow away the ambient heat around the heat sinks is enough to bring it down. So we've gone up 10 milliamps in probably a little over 60 seconds, if that, I wasn't counting. But now I'm going to put the cooling back on again, so you can see that come back down. So here we go, cooling just switched on. Just switched on. It's exactly the same voltage and everything else. But look at that, look, as it comes down, just having a bit of air. Now I can't hear that fan on the go because it's just slow enough, just have a bit of air movement, but not fast enough to be blowing anything around particularly, but just enough to get rid of the hot air around the heat sinks. So with that in mind, and we've got there, what's that, 69.5. With that in mind, let's start putting up the input, because then you're going to get to see when this distorts at 70 volts. Let me just For some reason it's gone off that parameter. So there we go, and we're going to keep an eye on this as well. I don't know why that's right, because that's not actually switched on. Probably a good idea if I do that. Then we're going to see a big jump there. So I'm just going to turn that on to 1 amp range. And you're going to get to see how that goes up. So we're on 500 millivolts going in. 6, 7, 8, 9. That's 1 volt. 1 volt, and we're on just under 400 milliamps. And as you can see already at 8.46, we've started to get that funny looking thing going on. We've got 600 milliamps, 700 milliamps, and look, that's at 70 volts. So really, if I back that off to where it'd be reasonable on the other one, was about there. We've got 7.42 volts RMS coming out. So if I turn that up to what we were at 80 milliamps, 800 milliamps, just under, but put it just under. Look, we got 9.92 volts at 70 volts, 35 volts aside. So it certainly does make a difference on this particular circuit, the input voltage. But that's of no fault whatsoever of the design of the circuit, of the way it is on the website. This is just the way this is set up here. On the website, it's set up for the way that they've set it out, for the components that they've used, and I've not used the way they've set it out. I've not used their board. I've not even used the recommended, all the recommended components. Some of them are, some of them aren't. But does it affect the way the audio quality is with this? No, not in the slightest. One, I run it at this particular 55 sort of volts, 55, 56 volts. I suppose just while I'm doing this, just take it back up again while it's at this particular voltage, and you're going to get to see again. Why does it always go back to that parameter? So I'll leave it on there so you get to see again that difference. So look, we're on 9.97, there's absolutely no sign of distortion, and we're on 600 milliamps. Sorry, I'm looking at my scars of a misspent youth, but I guarantee that my youth was probably nothing like yours. 12.6, and so there we go, we got a little slight bit of clipping there at 13.2. Now, if I turn it up, do we get rid of that clipping, or if I turn it down? If I turn it up slightly, okay, that's not so good, and if I turn it down slightly, I'll get it on the balance there, to where that could be almost passable, and I could probably fine tune it on here by just going, so let's say I'll put that onto 13 and just see if I can just fine tune, and we're on at 1.97 instead of the 2 volts. And remember the other one could do, what was it, 2.6 volts was it? So let me just see if I can just fine tune using the voltage. We've got just under 800 milliamp there, sort of 7, what's that, 75, 76, 77 over there, just under 80 there. With the cooling, remember the cooling was on, so that's good. And it's on the heatsink as well. So I'm just going to turn this up slightly, see if that helps out. Nope. And I'm going to turn it down just very slightly to what I think is probably the most tuned part of that. There we go. And that's at 13 volts RMS with a slight little bit of down the bottom. Okay, so I'm going to just back this off and just watch this go down. In actual fact, let me just see what that was at 13, 12.6, 12.7, 1.93, just under, yeah, so I was just looking basically at the current, just seeing what it was doing there for that little slight bit of adjustment. So there you can see, look, this is 56.4. So that's the sort of voltage that I need to be looking at when I'm setting this up for my transformer, because it's going to be specifically for this for this particular board, because there's no point me setting it up for the one that can do the more power if this one's going to be the problem. But like I say, that's running at full board on the input, so really it's not going to affect you, because when I sit here at home and I'm listening to this at a loud volume, I'm probably getting this thing to push up to I think the maximum I've taken it up to at number 40 input from my laptop is around about 300 milliamps, and now this will go to like 700 milliamps without any distortion quite happily if you look at it like that, the way it works through there. So that, well, let's just pretend it's number 80 on my laptop. That is way too loud. That is really pushing things and way too loud. So it's far more than what I need. And at the quality of the sound that comes out of this, I have not been triggered by anything else that I've built to get all my CDs and FLAC copy them onto my laptop to be able to listen to them, and then sit on the sofa which is behind me and just listen to my music again. And listen to and hear things in my music. I didn't believe it. I didn't realize in some Bob Marley tracks they're playing a comb. It's a comb down a comb. You can hear it. It's and some of the old 60s stuff. I've just spent quite a lot of money buying up a whole bunch of stacks, soul CDs, because I love that sort of music. Because I've never heard it really sound so good. I thought when I was younger I had a decent hi-fi setup, but that was old technology. But even with this, it does sound pretty good. So there we go. That's my little insight into this. I hope you found it useful. I hope if it doesn't, just because this one isn't the same output as the other one. I think the reasoning behind that is because this is a different layout slightly. I mean, there could be quite a few reasons for it, but it shouldn't put anybody off maybe building these, because I've not managed to match both channels.